Hi friends, now let's get to the next part of the series. So what is there on your screen? Yes, of course, very much familiar image, very much familiar thing. That's a map. So that's a Google map we have, and here we are trying to show uh, rail route from one point to other point, and this whole thing is being done by some magical thing called GPS. GPS is a short for Global Positioning System. It's a space-based navigation system which provides location and time information in all weather conditions. So whatever be the weather condition, it doesn't fail. Many times we have seen that our mobile signal are not trustworthy because of because of the atmospheric conditions, weather conditions. Sometimes the TV signals are not available because of the weather conditions. But whatever be the situation, one thing is very sure that GPS will be working. So that's GPS, which is always functional in all weather conditions, anywhere on or near the Earth, where there is an unobstructed line of sight to four or more GPS satellites. The system provides critical capabilities to military, civil, commercial users around the world. That's a old story, but today every individual is living only because of the GPS. So when a person is traveling from one point to other point, or whenever we want to share our position in any city, we depend on GPS. Or when you want to share your address to somebody, we prefer to send the GPS location so that using that GPS location and any map like Google Maps application, we can find our route to that particular position. So we can. So that's so much of highly useful system we have. It's only possible because of GPS. So the United States government created the system, maintains it, and makes it freely accessible to anyone with a GPS receiver. But today, even Indian government through ISRO have a similar system available. So for any given point at any time, these systems allow us to know the exact location of that point with an accuracy of few meters or even less than that. The whole CPS system works because of 24 active satellites along with the terrestrial stations to control them, and the positioning is based on trilateralization. So distance measured from a GPS unit to a certain number of satellites. So the orientation from a point to known minimum 3 satellites, orientation is identified, and using these orientations, the almost accurate position can be pinpointed on the Earth. So knowing these distances or the orientations, exact position of the satellites, the position of the unit can be computed. The positions computed with XYZ coordinates, so that's a Cartesian system. And GPS system uses WGS84 for its reference ellipsoid. So because these satellites are going to take elliptical paths, so we need that. So this is an example where 24 satellites are moving in their orbits around the Earth, and these 24 satellites are decided, and their orbits, their orientation, their speed, their positions are so decided that any time, any point on Earth, at least 3 satellites are facing it. So from any point, any time, if you just look upward, out of 24, at least 3 satellites are above the horizon. Therefore, we can track them, we can find the orientation, and then accordingly decide our own position. So this GPS satellites fly in medium Earth orbit at an altitude of around 20,000 kilometer. Each satellite circles Earth twice a day. The satellites in the GPS constellation are arranged in 6 equally spaced orbital planes surrounding the Earth. Each plane contains 4 slots occupying baseline satellites. So this 24 slot arrangement ensures users can view at least 4 satellites from virtually any point on the planet. Yeah, minimum 4 satellites are above the horizon anytime from any point on the Earth. So the GPS control segment system consists of a global network of ground facilities that track the GPS satellites, monitor their transmissions, and perform analysis and send commands and data to the constellation. So that way we can make out where we are. So these are the control segments of GPS system run under US based GPS system. So there is one master control here at Colorado. Then we have ground antenna, one at Florida, one at Ascaston, one at Bajalian, and one at Diego Garcia. Then we have Air Force monitor stations, 1, 2, 3, 4, 5, 6 Air Force monitor systems are used. Alternate master controls, so 1, 2, 1 alternate monitor control, AFSCN remote tracking stations. So there are 1, 2, 3, 4, 5, 6, 7 such things. And NGA monitor systems, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So all these together work in unison and make sure that anytime each satellite's position is recorded at every instant of time, and accordingly it from any point on the earth, when we look up, we see some satellites, and our device, the GPS system, the device having GPS system is trying to look for these satellites, and when it finds the satellites, it will find the time to travel from the GPS unit to the satellite and return back. So the echo is returned back and time taken is measured, and that way we know distance between the point and the satellite. So that way all 4 satellite distances are measured, and taking all these 4 distances together, we can make out the orientation of the 4 satellites, because we know where the 4 satellites are at that instant, and then accordingly we can identify that from each satellite so much distance away. If you just find out that it's going to pinpoint one position on the earth in accuracy of meters, we can get all this possible. So how that's done? Triangularization is one method. So where from the location we look for minimum 3 satellites above the horizon, and then we check the orientation where the 3 satellites are visible from that point. So looking at these 3 angles, we form a triangle, and that will tell us the exact position where our location is. So that's one of the interesting activity we have with our mobile system. So that's going to tell us where we are. So today, because of GPS, human can dare to enter any terrain anywhere, because he has one assurance that through GPS and maps can be uh, saved, can reach any destination. So that's where the GPS helps us. So that's it for now. We have many more issues to look at. So keep watching. Thank you.